Now we shall see some of the problems we have written here. We will see one by one. See, integral he has given e to the power of x divided by e to the power of x minus 1 into dx. Here we put e to the power of x minus 1 is equal to t. Now when you differentiate e to the power of x, it will be e to the power of x only into is equal to dt by dx. Therefore, e to the power of x dx is equal to dt. Like this we get. E to the power of x minus 1 is equal to t means, if when you differentiate both sides, e to the power of x is equal to dt by dx. Therefore, e to the power of x dx is equal to dt. Now I will keep here e to the power of x dx is equal to dt divided by t. Now we know dt by t is nothing but log t plus c, or log of e to the power of x minus 1 plus c. This is the answer. Now we shall see the second problem. Integral 1 over e to the power of x plus 1 into dx. This is the second problem here. See here, what I am going to do, I will add e to the power of x minus e to the power of x divided by e to the power of x plus 1 into dx. You can see here, I have not changed any value here. E plus e to the power of x minus e to the power of x. Now we will separate this. E to the power of x plus 1 divided by e to the power of x plus 1 into dx minus integral e to the power of x divided by e to the power of x plus 1 into dx. This we have made it separate. Therefore, this gets cancelled. Integral 1 into dx minus, now this is a separate integral we have to do. For this, what I am going to do, integral e to the power of x by e to the power of x plus 1 into dx. I will do it separately here. Integral e to the power of x divided by e to the power of x plus 1 into dx can be written as, put e to the power of x plus 1 is equal to t. E to the power of x dx is equal to dt. E to the power of x dx is equal to dt. Therefore, dt by t, which is equal to log t plus c. This is log of e to the power of x plus 1 into is it plus c. Now here we will do that. Integral x minus, it is x minus log of e to the power of x plus 1 plus c. This is the answer for that problem. Now we shall see the third problem. Integral dx by x plus root x. Now this we can write like this, dx by root x plus root x into root x plus root x. See here, root x into root x is nothing but x plus root x we have written. Now dx by, I will take out root x common, root x plus 1 will get here. Now put root x plus 1 is equal to t. When we differentiate this, 1 over 2 root x is into dx is equal to dt, or 1 over root x into dx is equal to 2 into dt. Now I will substitute like this. We will do it 1 over root x into dx by root x plus 1. See, this we can write it as like this, 1 over root x dx, 1 over root x dx is equal to 2 into dt, 2 dt divided by t, or 2 log t plus c, because integral dt by t is nothing but log t, 2 log t plus c, or log of t square plus c, or log of t is what? Root x plus 1 whole square plus c. This is the answer for that problem. Now fourth problem, integral dx by e to the power of x plus e to the power of minus x. This is fourth problem. Here you can see here dx by e to the power of x plus 1 over e to the power of x. We will write like this. E to the power of minus x can be written as 1 over e to the power of x. Now we will take LCM. Dx by, I will take LCM. This becomes e to the power of 2x plus 1. It becomes. Now integral, this goes to the top, e to the power of x dx divided by e to the power of x whole square plus 1. We can write like this. Now put e to the power of x is equal to t. Therefore e to the power of x dx is equal to dt. E to the power of x is equal to t I have kept. E to the power of x dx is equal to dt. Therefore dt by t square plus 1. For this formula is tan inverse of t plus c. Tan inverse of t plus c. That is tan inverse e to the power of x plus c is the answer to this. Now we shall see the fifth problem. Now here I am writing like this, e to the power of x divided by e to the power of x whole square minus 3 whole square. We can write this problem like this. E to the power of 2x can be written as e to the power of x whole square minus 3 square. We can write. Now put e to the power of x is equal to t. E to the power of x dx is equal to dt. Therefore dt by root of t square minus 3 square. It is nothing but dt by root of t square minus 3 square, which is equal to, this is in the form integral dx by root of x square minus a square, which is equal to log of x plus root of x square minus a square plus c. This formula we are going to use it here. So that is log of t plus root of t square minus 9 plus c, or log of, we will put it in the bracket, log of t is what here? It is e to the power of x. So e to the power of x plus root of e to the power of 2x minus 9 plus c. This is the answer for that problem. Now we shall start with sixth problem. Integral dx by root of 4 minus 3x plus 2 whole square. See, this is the problem. Integral dx by root of 4 minus 3x plus 2 whole square. Now here what I am going to do, put 3x plus 2 is equal to t. What happens to this when we differentiate? 3 into dx is equal to dt. 3 into dx is equal to dt, or dx is equal to dt by 3. Dx is equal to dt by 3. I am going to substitute here dt by 3 divided by root of 4 minus t square, or we will write like this: 1 by 3 integral dt by root of 2 whole square minus t whole square. This is in the form integral dx by root of a square minus x square is equal to sine inverse x by a, which is equal to 1 by 3 sine inverse t by 2 plus c, or this we can write like this: sine inverse, sorry for here, see, it is 1 by 3 sine inverse x by a. X instead of x we have t here, t by a is 2 plus c. Sine inverse, instead of t I am substituting 3x plus 2, 3x plus 2 divided by 2 plus c. This is the answer. Now we shall see this seventh problem. It is a very difficult problem. Integral x square plus 1 divided by x to the power of 4 plus 1 into dx. This what we are going to do, we divide by x square numerator as well as denominator. We are dividing it by x square, both numerator and denominator. So x square by x square plus 1 over x square divided by x to the power of 4 by x square plus 1 over x square. Now what this becomes, it becomes 1 plus 1 over x square divided by, this becomes x square plus 1 over x square into dx. Now here we are going to do this adjustment here. Integral 1 over 1 plus 1 by x square divided by x square plus 1 over x square I have written as it is. Now minus 2 plus 2 I am making this adjustment here, so that the value doesn't change here. So when we consider only this x square plus 1 over x square minus 2, it becomes x minus 1 by x whole square plus 2. So integral 1 plus 1 by x square divided by this entire thing becomes x minus 1 by x whole square plus 2. Now I am writing like this: integral, I am putting x minus 1 by x is equal to t. X minus 1 by x is equal to t. When we differentiate this, 1 plus 1 by x square into dx will be equal to dt. That is what we have written here. 1 plus 1 by x square into dx is equal to what here? It is dt integral divided by, this becomes x minus 1 by x whole square. X minus 1 by x is t. So it becomes t square plus this 2 I am doing like this, root 2 whole square. Root 2 whole square. This is formula is 1 over root 2 tan inverse t by root 2 plus c, or 1 over root 2 tan inverse, what is t is equal to, we have kept here x minus 1 by x, that I have substituted, divided by root 2 plus c. That is the answer. Now we shall see this 8th problem. Integral 1 over x to the power of 4 plus 1 into dx. This what we are going to do, we are going to split into first and second part. See here, I am going to write like this: half of integral x square plus 1 divided by x to the power of 4 plus 1 into dx minus integral x square minus 1 divided by x to the power of 4 plus 1 into dx. These are the two parts we are making it. So that when I cancel this x square minus x square, 1 plus 1 will be 2, 2 and 2 get cancelled, you get the problem, same problem. So this adjustment we have made here. And this first part already we have done in the 7th problem, you can refer back. But anyhow, for your reference I have done this problem. You can see here, integral x square plus 1 divided by x to the power of 4 plus 1 into dx is equal to, I am dividing both numerator and denominator by x square, so that you get 1 plus 1 over x square in the numerator divided by x square plus 1 by x square in the denominator. For that I have made a adjustment here, minus 2 plus 2. Why this adjustment? Here you are going to see here, integral 1 plus 1 over x square into dx divided by a square plus b square plus 2ab, which is nothing but a minus b whole square, x minus 1 by x whole square plus 2 we have done here. And this, put x minus 1 by x is equal to t. What will happen? When you differentiate this, 1 plus 1 by x square into dx is equal to dt. So dt divided by, this becomes t square plus 2. 2 can be written as root 2 whole square. 2 can be written as t square plus root 2 whole square. This is in the form, already we have seen, integral dt by a square plus x square is nothing but 1 over a tan inverse x by a plus c. Here, what is a? It is root 2. So 1 over root 2 tan inverse x is t divided by a is root 2 plus c. So now I am going to substitute for t is equal to 1 over root 2 tan inverse. T is nothing but x minus 1 by x. X minus 1 by x divided by root 2 plus c. The first part problem is over. Now we will come to the second part. Second part is integral x square minus 1 divided by x to the power of 4 plus 1. Now here also same thing. Divide denominator, numerator and denominator by x square. We get 1 minus 1 by x square divided by x square plus 1 over x square plus 2 minus 2. I have made this adjustment here. Here it is minus 2 plus 2 in the previous this one. Here it is plus 2 and minus 2. You can see a square plus b square plus 2ab is nothing but a plus b whole square. So integral 1 minus 1 over x square divided by x plus 1 by x whole square minus 2 I have written here. Now put what x plus 1 by x is equal to t. Put x plus 1 by x is equal to t. What will happen? Integral dt by t square minus root 2 whole square. Because when you differentiate this, it becomes 1 minus 1 by x square dx is equal to dt. The entire thing becomes dt divided by x plus 1 by x is equal to t. It is t square minus root 2 whole square, which is equal to integral. This is of the form integral dx by x square minus a square, which is nothing but 1 over 2a log x minus a by x plus a plus c. So therefore, what happens here? You can see 1 over 2 root 2, 1 over by 2, root 2 is a. So 1 over 2 root 2 log t minus root 2 divided by t plus root 2 plus c. But t is what we have kept here, x plus 1 by x, that we have substituted here. 1 over 2 root 2 log x plus 1 by x minus root 2 divided by x plus 1 by x plus root 2 plus c. Now, the entire problem is combining first part and second part. See again, integral 1 over x to the power of 4 plus 1 dx can be equal to half of, here, this half of 1 over root, this we have combined